Hello everyone, my name is Swara and today we will continue factors and multiples. In the first video, we learnt what are factors and we defined a bit of multiples. In the second video, we learned the divisibility test, and in this third video, we will learn how to find prime factors of a number. So what is a prime factor? A prime factor of a given number is called a prime factor if this factor is a prime number. What does it mean? It means when there is a number and we are finding the factors and that factor is a prime number, then it is called a prime factor of that number. It is mostly written in multiplication form by using the into sign. Next example, 4 equals to 2 into 2. 2 is also prime factor, 2 is also prime factor. 6 equals to 2 into 3. 2 is also prime factor, 3 is also prime factor. 8 equals to 2 into 2 into 2. It's also prime factor. Now let's try these 3 examples again. 9. I know 3 into 3 into 3. 3 into 3 equals to 9. 10 equals to 2 into 5. I'll check with the smallest prime number and then with which prime number I'll multiply, I'll check that. 12. Now 2 into 6. But 6 is not my prime number, so I'll factorize this 6. So I know 2 into 3. So 2 into 3 I'll write. So 2 is a 4, 4 3 is a 12. Now when you will multiply these digits, we get the third property that when you multiply the digits given to you, which are the prime factors, you will get the same number which you factorized or which you found the prime factors of. Now we will learn the methods to find prime factors, and at the end of the video, I suppose we will take the divisibility test of 7, 11 and 12. Okay then, let's start this topic with how to find. So see here. Factor tree method. The method to find the prime factors of a number. There are two methods. First is prime factor, second is prime factorization. So first we will learn about prime factors. Question says, find the factors of 24 by factor tree method. And such a question when we will come to your exam, so what you will do? Listen. Please concentrate, okay? And pay your full attention. We'll write 24. Draw a circle around it. Okay? Then draw your two factors, like two branches kind of thing. Right. First smallest prime number you think. 2. Put an into sign in between. Next, divide it with 2. You get 12. Then what to do is factorize this 12. This is the easiest method, okay? There are two methods also finding. Another prime factorization by factor tree, you can find it like this also, and another factor tree is also. Now draw two circles again. Multiply sign in here. 2 6 are. Here. 2 into 3. Now these numbers and the last number from that place is my prime number. Understood? So prime factors of 24 equals to 2 into 2 into 2 into 1 to 3 now. into 3. And if you multiply 2 to 4 to 8, 3 is 24. Another method is draw a circle. Whichever table comes to your mind. 6 4s are 4 6 are. So take that. 6 4s are. If I take 6 into 4s are. Then factorize 6 and then factorize 2. 4, sorry. I know 2 into 3 or 3 into 2, so write any of these. I'll write 3 into 2. Put a multiplication sign here. Into this number. 4 of them. 2 into 2. Now why I put this multiplication sign? If here also I was getting any composite number, then I would have not put in it. I would have continued until at the bottom I will get the prime factors. And once I get the prime factors, I will put the multiplication sign in between and see the prime factors of 24. 3 into 2 into 2 into 2. 3 2s are 6, 6 2s are 12, 12 2s are 24. This is the factor tree method. Let's solve one more example by whichever method you are solving. So let's see that. First question. Factor tree. Find the prime factors of 84 by factor tree method. So first of all, I'll write 84 here. Nice circle. Draw 2 bars. Okay, wait. 2 into 2 4s are 8, 2 2s are 4. 2 into 2 2s are 4, 2 1s are 3 into 7. Now 7 is a prime number. Now I cannot factorize it rather than 7 into 1. So prime factors, or you can also simplify it like this, 7 into 1. But when you do this, remember, you are not taking this line. Eliminate this row, take this one part, okay? Because one is neither prime, neither composite, okay? So prime factors, anyway you do it, you will get max. Prime factors of 84 are 2 into 2 into 3 into 7. Multiply it. 2 to the 4. 4 3 is 12. 12 7 is 80. Now we learned how to find prime factors of a number. Now we will learn how to find prime factors of a number by prime factorization method, which is more useful than this method also. But when in your exam pattern, it may ask you to do it by the factor tree method or do it by the prime factorization method. One method is given to you. So please do that. But when it is like a MCQ or it directly asks what are the prime factors of this number, so you can follow which method is easier for you. So let's learn what is prime factorization method. See this. Methods of finding prime factors. Prime factorization of 84. So we'll draw a bar. We'll draw another. First I'll draw a vertical line, then I'll draw a horizontal line intersecting here only at the topmost point, not in the center. I'll write whatever is my number here, like 84. I'll draw another line. Then I'll draw another and another like this. Now, in which table does 84 come? First and lowest prime factor we'll check. It is 2. So we'll write here 2. So 2 4s are 8 and 2 2s are 4. Then 42 again goes with 2. We learned the divisibility test now. Here is 2 in the units place, goes with 2. 2 2s are 4, 2 1s are. Now there is no 2 in the or 2 or it's not a even number, so it's not divisible by 2. Here it's a 1. So I know 3 7s are 21, so I'll write 3 and 7. Then I'll write 7 1s are 7. 7 you have. Now here I got a prime number. So when I get a prime number here, I'll just say prime number into 1 equals to that prime number. So 7 into 1, 7. So prime factors of 84 are 2 into 2 into 3, 2 to the 4, 4 to the 12, 12 7s are 84. Let's try another example and follow this method, which will make it more and moreover clear to you. See here. Find the prime factors of 108 by prime factorization method. 108. So I'll say draw a bar. Draw a bar. My first major step. Place my number and divide. Start dividing. Smallest is 2 and it goes with 2 because there is 8 in the units place. How much times? 5s are 10, 2 4s are 8. Again there is 4 in the units place, so it goes 2 2s are 4, 2 7s are 14. Now it doesn't go with 2 because there is no 0, 2, 4, 6 or 8 in the units place. But I know 3 9s is 27. 9s are. Then 3 3s are again. Now here I have a prime number. So prime number goes with a prime number. Therefore, prime factors of 108 is 2 into 2 into 3 into 3 into 3. Now when you have a prime factors like these which are repeating, you can write them in powers. Like now it is repeating 2 times, so we will write it as 2 square into 3 times 3 cube. Right? This is also possible. This is also the right answer. This is also the right answer. You can follow any of this method. But if you are in class 3 to 4, it is okay to write in this method. But for class 5, 6 and 7, I like you to say, do it in this method. Now what is this? This is nothing but the concept of squares, cubes, or a number. Squares mean a number like x raised by the power 2. X raised by the power 2 means x into x. Understood? Cubes raised by the power, say x cube, it means nothing but x into x into x. X raised by the power 3, number itself multiplied 3 times. X raised to the power 2, x multiplied to itself 2 times is known as this. Now 4 times, 5 times. Now these numbers were repeating 2 into 2, 3 into 3 into 3. So what I said, rather than writing them as like this for class 5, 6, 7, I'll say it is 2 square into 3 cube. And even class 3rd and 4th can follow this because their brain will get more evolved that when they'll go to the senior classes, they'll find this very much easy. And I like you to do with this method only. This is very easy now, right? So do something rather than accepted. Next. Now next we learned prime factorization. We also saw how to find the prime factors of a number. Now what we have to learn? We have to practice. Now, I like you to teach. I want you to teach how to find the prime factorization of a number in the concept of power. So, let's understand. Now, here you can see any number raised by the power means the number multiplied to itself. If I raise myself to the power 3, okay, here is 3. So, it means I have 1, means 2 and again means 3. So, these are the powers. Let's understand it in mathematical language. X cube. X cube means x into x into x. Rather than writing x, if I got same in all the cases while finding the prime factors of a number, so I'll say it's x cube direct. If I have 2 times x, so I'll say x square. If I have 4 times x, I'll say x into x into x into x I have. So I'll say it is just x raised by the power 4. How will we read it? x4 reading. We don't say x4 or x2 because it is, and also do not write it like this x. This is wrong, okay? It is in the topmost place, you can see, right? So reading is x raised by the power of x raised by the power of 4. This is how we will read it. Like say, I want to say 2 and say 8. So, reading 2 raised by the power 8. Okay, this is how we'll solve these questions. Now there are another rules we'll see when you have the same base, what to do in the case of powers. Now the second rule is, when I have suppose to do when my number is like what we can say is like raised with power 0. When in a fraction case, we saw that when a number is raised, when the denominator is 0, it is infinite. So, is this same? Okay. Rules with 0 are very different. So, see this. Any number raised by power 0 is 1. So, example 7 by power raised by the power 0. No, it is 1. 1000 raised by power 0 is 1. 180 raised by power 0 is nothing but 1. So, any large number you take, maybe I don't know the place even, but still it is 0 and a 0. Let's learn the third basic rule of concept of power. Third rule. When the base is same, add the powers. Base. Now this one, I am the base. The number raised by me this is the power and I am the base. So I am the base now. I am the base. So if my base is same in all, so I am same in all. So that time I'll add my powers here was 2 suppose in there. So see this example. 2 square, 2 cube, 2 raised by power 4. Now see. I know this is 2, this is 2, this is 2. Base same. Yes. Addition of powers possible. is possible. Okay, yes. So then what I'll do is, okay, addition of power is possible. You can say like this also is possible. You can add if you are much concerned about the English. 2 square, 2 square, 2 square. Write 2. Base won't change. Only the topmost digit will change. So it's 2 plus. Now what will happen? 2 plus 6. Now base is same. So I will take one base. Bracket. Powers will add up in themselves. 2 plus 3 plus 4. I don't care the matter that is this same or not. Okay. 2 plus 5 plus 4. Okay. Then equals to 2, 5 plus 4, 9. 2 raised by the power 9. Oh my god, that's much bigger, right? Now, what is this? We found just the number in just one place. Now, another possibility what have gone through is, what if 4 cube into 5 cube into 6 cube. Now this is not possible with this way, because I said the base is same and the line is base is same. Then add the powers, and when base is not same, then do not add the powers. So same, in the same case, we will have to simplify this as it is. Now, we will say, what if I have a number which is prime, and finding the factors of that number, is it possible or not? So let's learn it. So let's do it with an example. 2 and 3. I will, in any way, if you do, let's try it with this one. 2 into 1. 2 ones are. Now you might wonder, what is this? 1, 2 into 1. But I'll say no. Here is what mistake. It's 2 itself. Because 1, what you can do is, you can do is 2 raised by the power 1. It is never 2 into 1. Never ever. Because 1 is neither prime nor composite. While finding the prime factors or any factor, while finding the prime factors in the multiplication form, I need a prime number. It's neither prime nor composite. So what I have to do with it? Nothing, no? So what I can do is 2 raised by the power 1. Let's write it 3. So I'll just say 3 raised by power 1, because I cannot write it 3 into 1, right? This is wrong. That is the reason we are using these kind of things, using the concept of power. And at the end of the video, as I had told you before, we will see some of the examples, the divisibility test, and now let's start them. And also in the next video, we will be having questions on prime factorization of numbers by any of the method using the powers. It is even useful for class 3, 4, 5, 6, 7, very useful. So please join that session. Now let's move on to our divisibility test of 7, 11, 12. So this is an example, and in this example we will learn the rule. 6804, and I am putting the divisibility test of 7, okay? I know I have to divide. So I'll write 6804. Which is my units place? I double that or add them up. So I'll say 4 into 2. Because 4 into 2 equals to 4 plus 4 equals to 8. So I'll bring this number down. I'll do it minus 8. 10 minus 8, 2. 7, 6, 7, 2. No, I also don't want to divide this. So I'll bring down this number. 2 into 2 is to 4. Bring 6 to 7 minus 4. 7 minus 4, 3. 63. Now you know this, that 63 comes in 7 table. Now you will say 63 upon 7, which equals to 9, equals to remainder equals to 0. And even if I took 672 upon 9 is 7 is completely divisible. So if you get here larger number, then do it this, continue the same steps. Very easy. Let's try one more example and end divisibility test of 7 and then start divisibility test of 11. Let's see that fast. 2 is given to me. I'll write the number here, okay? 7, 1, 2, 3, 2. Divisible by 7 or not. Take the units place. Write down this number as it is first. Take 2 place, second, multiply 2 with it, getting 4. Subtract 4 from this. 13 minus 4, how much will you get? 13 minus 4, you will get 9. So writing the answer here, 9. Then this became 1, 7, 1, 1, 9 you will get approximately, right? Then I know I cannot do this much wrong, so I'll take 9. I'll write down this 7, 1, 1 as it is. 9 2s are minus 18. 11 minus 8, 3. So this became a 0. Then it gave there 10 minus 1, 9. This became 693. Again the same case. So I'll multiply 3 2s are 3 into 2, so 69 equals to 9 minus 6 equals to 3, 63, which is divisible by nothing but divisible by what we say 7, 63. Yes, this number is divisible. Let's learn the divisibility test of 11 and 12. Then we will end our video as well as our topic of divisibility test and how to find the factors, prime factorization concept even. And then we will move on to our new topic. Okay, then let's start. See this example. 90728. Very easy. First, find the sum of odd places, sum of even places. What are these odd and even places? I know you might be wondering. I am writing, okay? The units place. Remember, note down the units place. I am repeating here. The units place is always odd when you are finding the number is divisible by 11 or not, or putting the divisibility test of 11. Last place or the units place or the ones place, whatever you might be calling it, should be odd place. Must be, okay? Now 90728. So this is odd. This is even, okay? This is odd. This is even. This is odd. Now what to do is odd, whatever odd places minus even places. Now what happens in this is whichever number, odd or even, which is greater first. Like here odd means x plus y plus z, whatever numbers you have. Even means x plus y plus z, whatever numbers you have first. So let's put up odd places sum. I'll say C is 9 plus 8 plus 7. 8 plus 7, 15. 24. Even places 0 plus 2, 0 and 2 only. 2, and here I put minus. So 24 minus 2. So it is nothing but 22. Now I'll see, is this number divisible by 11 or not? Yes. So this number is divisible by 11. Good job. Now same with other examples also we can do. Now shall we move on to the divisibility test of 12? Because this is much same, and remember the 7 and 11, they are much complicated. Just remember units place is odd, so another place is even then odd, then even, then odd, then even, and this pattern continues. This is a very easy divisibility test of 12. It is much similar like the 6. If I factorize 12, what I'll get? 2 into 6, 2 into 3. But which is much main, right? 1 you will write 4 into 3. If you follow this, see, I keep these notes with me. I had also made notes in which whatever I learnt till my senior grades. So see, any number which is divisible by 4 and 3. It means 4 and 3, I'll put the divisibility test. 3. Sum, so 1 plus 4 plus 4 plus 6 plus 1 plus 2 plus 0. 0 has no value, so gone. 4 plus 4, 8. 8 plus 1, 9. And 9 plus 1 is 10. So 10 plus 6 plus 2 is 8 plus 0. 18 only you will get. And which is, now here I'll write 18 upon 3 is possible. Right? So, now 4 means the last two places, 20 upon 4. Remainder equals to 0. So gone. So this number is divisible by 12. Same with other cases as well. So for finding the number is divisible by 7, we will double the units place, subtract whatever we get from the other remaining places, and if the other remaining places are also in large number after subtracting, repeat the same progress. Then we saw the divisibility test of 11. The units place is an odd place. So, do factorize it as odd, even, odd, even, odd, even. Do it as how much the large the number is. Find the sum of odd places. Find the sum of even places. See which sum is greater. So, whichever is greater, from that you will subtract the smaller. And whatever answer you will get of that subtraction, what you will do is, you will see if it is divisible by 11, and if it is divisible by 11, that whole number is divisible by 11, or is it 0, still it is divisible by 11. Okay then, bye bye.